Okay, so in the last video, I told you guys that there are some variables that have multiple answers. And I know what you might be thinking. You said, wait a minute, I thought a variable was just a number we didn't know, as in a single number we didn't know. And that's true that a single variable is a number. So, like x is a number. But sometimes multiple numbers can be described using the same x. And today we're going to look at a couple different situations where that's the case and explore kind of how that works. Usually it's with square roots is where you see it a lot, absolute values where you see it a lot. Although inequalities are a bit strange, but we'll talk about those when we get to them. For now, let's start with square roots. So in a previous example, let's go to the board. Okay, so in a previous example, we had written on the board, we had x squared equals, I want to say it was 16. And then we had x equals the square root of 16. So we wrote x equals 4. Now, that's true, but it's not the only answer that we have here. So we can also use -4. Now, the reason for that is because we started off with x squared equals 16. So this needs to be true, right? So if I do 4 squared, that is the same as 4 times 4, which is, of course, 16. Then, if I do -4 squared, well, that would be -4 times -4. Negative times a negative is positive, so that would leave us with positive 16. So actually, both -4 and +4 would both work as answers, so I need to list them both in this situation. The way to remember this is basically anytime you take a square root, what you want to do is right in front of it, and I'll write this in yellow so that it stands out a bit more. You want to write plus or minus because the positive and negative version of this square root are both valid answers. So the square root of 16 is 4, so -4 works, and +4 works. So x equals both of those numbers. So if when you take a square root, you write plus or minus, that allows you to know, hey, actually the positive version of the number works and the negative version of the number works. So in cases like these, you should be putting both numbers. I didn't do this last time because I wanted to separate these two topics, but just know when you take a square root, you need to write both numbers because positive and negative, both very, very important. And there's some other stuff you can use with that. We're not going to be doing that right now today. We might do it later on. But yeah, so that's how you get multiple answers with a square root. So moving back to our presentation. Absolute value is very different. So this is another situation where what we're describing means that there's going to be more than one way to do it. So let's go back to the board. So absolute value just means the distance from 0. So let's say I have a brush to work with. Let's say we have a number line. And right smack dab here in the middle is 0. So let's say this is +5 and this is -5. So the distance from 0 to 5 is 5. It's 5 away. The distance from 0 to -5 is also 5. So -5 is 5 units away from 0, just like +5 is 5 units away from 0. So the absolute value sign, which looks like this, by the way, the absolute value of 5 is 5 because guess what? If I move 5 units, I have to move 5 units away from 0 in order to get to 5. Now, the absolute value of -5 is also 5 because I need to move 5 units away from -5. Or I'm sorry, move 5 units away from 0 to get to -5. Basically, absolute value doesn't care about direction. If you wind up with a single number that is negative inside of an absolute value, you just treat it like it's positive. That has some interesting effects on us whenever we're solving problems. So let's say that I have, the absolute value of x plus 1, and that is equal to 4. So that means that the distance from 0 of this guy, so x plus 1, is 4. So that means if I have 0 right here, the distance away from 0 is x plus 1. Now, that applies both ways, so x plus 1. So there is a positive answer where x plus 1 equals positive 4, but there's also a negative answer where x plus 1 equals negative 4, because I move forward and I move backward. So anytime you get absolute value, and you want to get it by itself, so, you got the stuff inside the absolute value, you want to split that into two equations. So we got x plus 1 equals negative 4, and x plus 1 equals positive 4. So over here, we're going to subtract 1, both equations, both sides. So on the left side, x equals negative 5, because negative 4 minus 1 is negative 5. And then on the right side, we're going to get x equals 3. So now I have two answers that both make this true, even though they're not the same number. So in situations like this, the variable is describing a possible answer. It could be describing either one. And there are ways to check when you get multiple answers to see which one makes sense. But for right now, just know that there are two answers and that we need to list them both. So to give one more absolute value example that looks a little bit more complicated, but isn't as complicated, it just looks more complicated than it is. So let's say we have 2 times x minus 3, or minus absolute value of x minus 3, my apologies. Minus 3 equals, we'll say it's 5. Okay, so first and foremost, we need to get the absolute value alone. So this needs to be alone before we do the special stuff, which means we need to do reverse PEMDAS. So let's grab good old SADMEP. SADMEP. I don't know why SADMEP just makes me smile. It just sounds like a silly word. SADMEP. Anyway, so we're going to start subtraction and addition first. So we're going to add 3 to both sides. So plus 3 plus 3. So we got 8 equals 2 times absolute value of x minus 3. Okay, so need to get rid of the 2. So we did subtraction and addition. Now we need to do division multiplication. So 2 times whatever. So the opposite of times would be divide. Whatever do to one side, to do to the other. So absolute value x minus 3 equals 4. So now I'm going to split this up into the negative and the positive. So x minus 3 equals negative 4. And x minus 3 equals positive 4. So in both of these cases, I'm going to add 3, because we go back to good old SADMEP. Start with the subtraction addition first, and then add to both sides. So x equals negative 1, and x equals a positive 7. So those would be our answers for this guy. So basically, when you're doing absolute value, treat the whole thing as though it's x. So you want that by itself. Then once you get it by itself, split it into its positive and negative versions. And that's how you solve absolute value questions. We are not going to talk about inequalities just yet, because that's a little later. But for now, that'll do for the absolute values. So now we're going to cut back to the thing, and let's see where we're going. Now we're at inequalities. Okay, so inequalities. So normally when we do an equation, we're talking about what's called not inequality, an equality, as in one equality. So actually, I probably just should have stayed at the board. But anyway, so if we say if we say x plus 3 equals 5, that means that we can figure out that x is a single number. So we say it's a single number. Of course, if it's squared or absolute value, it might be 2 numbers. But then inequalities do something a little bit different. So now let's say we have that, but instead of doing x plus 3 is 5, we say x plus 3 is bigger than 5. By the way, this one means bigger. Bigger. This is bigger, this is smaller, this is bigger than or equal to, this is smaller than or equal to. So the underline means or equal to. If it's pointing to the right, that means the one on the left is bigger. If it's pointing to the left, that means the one on the left is smaller. So x plus 3 is bigger than 5. Okay, so now I'm going to try to solve that the same way I do an equality, not an inequality. So if I try to do it the same way, so over here, when I do subtract 3, I know right away that x is 2, right? So that's what an equality allows us to do. It allows us to get a single number or a few numbers. Meanwhile, with the inequality, if I do that, I get x is greater than 2. So up here on top, if you ask me what x is, I'll say, oh, it's 2. Very straightforward. Down here, meanwhile, if you ask me what x is, I have no earthly clue. I couldn't tell you to save my life. The only thing I could tell you is that whatever it is, it's bigger than 2. So now I know how to work these, because I work them just like I do normal equations for the most part. But now I have this issue of, well, how do I describe that to someone? Do I just say it's bigger than 2 every time? What if like I need to write that down? There are ways to write it, and there are fast ways to write it. But for right now, we're going to go over the last rule that inequalities have, because there is one rule that makes them different from equations. And then we'll go on to how the heck do I even write that answer? So let's say real fast. So let's say we have negative, no, not negative x. So I have 3 minus x is less than 2. Okay, so good old SADMAP. SADMAP. So subtraction, addition first. So this is a positive 3, by the way. So the opposite of plus 3 would be minus 3. So subtract 3, subtract 3. So negative x is less than negative 1. Okay, so we did our subtraction, addition. Now we got to do divide and multiply. Okay, so special rule here. Special rule. Writing this with all of the stars. I don't have time to draw all the stars and stripes, but know that I have all of the stars. Okay, so if you divide by a negative number, or if you multiply by a negative number, you must switch the arrow's direction. So normally we don't have to do this because guess what? Equals forward is the same as equals backwards. There's no difference. But if I have bigger than and all of a sudden I switch directions, because that's what you do when you multiply by negative 1 is you switch directions, then all of a sudden I need to change from this to this. So over here, I'm going to multiply by negative 1. When I do that, the x becomes positive and the negative 1 becomes positive as well. But this thing also switches directions. So x needs to be bigger than 1 here, which makes sense because the bigger x is, the lower the value of this side, right? So when you have to multiply or divide by a negative number, make sure you switch the direction of the arrow. I cannot express to you how important it is that you do not forget this. This is the part that makes students really struggle with inequalities the most, is they'll forget to switch their arrow around when they multiply or divide by a negative number. So just remember to do that, and everything else is just like equations, it's normal. And you'll be solving inequalities in no time. All right, and with that, that is how to work an inequality. So now let's talk about answers in interval notation. So giving your answer in a way that says, I don't know what number it is, but it's somewhere in here. When your answer is between two numbers, or between a number and infinity, which we're going to look at that, you can't just give a specific number and then call it a day. You have to say, no, it's between two places. And it does matter whether you use parentheses or brackets. And I'm going to go to the board because I feel like that's too many big words. Let's get some examples. Okay. So before we had, that's the wrong one. We had 3 minus x is less than 2. So we did that. So minus 2, negative x is less than negative 1. This should be minus 3. Sorry, minus 3. So we multiply by negative 1. And then, like I just said, we switch the thing around. And then x is greater than 1. Okay, so let's look at this on a number line. So according to a number line, x needs to be greater than 1. So here's 1. X can be anything on this side, right? So these are the positive numbers. So as we keep going to the right, we reach positive infinity. By the way, if you'd been going left, you'd have been going towards negative infinity. So everything that we're pointing at is good, but x itself, or 1 itself, is not allowed. And let me explain why. So this says x is bigger than 1. So if I tried to plug in 1, 1 is not bigger than 1. So this, not true. So I'm not actually allowed to use 1. That's why on this thing, I got the little stoppy thing before we actually get to 1. 1 is not a valid target. But here's the thing. When we're explaining this to someone, we need to tell them where we started. And we go, okay, so we started at 1, and we went to the right forever. So forever is just infinity. So we are going to use parentheses on these. Now, parentheses means you can't actually plug in that number. With infinity, infinity always gets parentheses because infinity is not a number. It's just the idea of a really big number. So anytime you have an infinity, positive or negative, you always slap a parenthesis on that thing. But 1 is actually kind of special here because when it comes to a specific number, we either use brackets or parentheses. Now, let me explain the difference. So the parentheses means can't use this number, so not usable. Usable. So as we saw before, 1 greater than 1, no. That's not true. That is why it gets a parenthesis. Now, the bracket means that it is usable. So if, for instance, it was x is greater than or equal to 1, 1 is greater than or equal to 1, that's true, that works. In this case, we would have a 1 with a bracket. But, because that's not what we have, we're not allowed to do that. So the long and short of it is, if you have, and I'm going to do this in not yellow, I'm going to make it in, I'm going to make it in light purple. So if you have a non-underlined inequality, you are going to use parentheses on that number. If you have a underlined inequality, you would have a bracketed number. So if it's underlined, you can use a bracket. If it's not underlined, you have to use a parenthesis. And this is basically how interval notation works. You just go, oh, it's somewhere between these two numbers. And we say infinity as a quote unquote number. Here, I'll put it in there in quotes. Infinity is a number. Infinity basically means, hey, it's 1 or bigger. That's what this means, is this means 1 or bigger. So if you have to write it for mathematics purposes, this is the same as saying 1 or bigger. In the same sense that something like this, or this says bigger than 1. Sorry, because we don't actually use 1 that says bigger than 1. So something like this down here says 5 or smaller. So this one says bigger than 1 because we're not allowed to use 1. That's why we have the parenthesis. And this one is 5 or smaller, and we include 5 because it's got a bracket. Okay? That's how interval notation works. It's a bit of a longer one, bit of a doozy, but I believe in you. You got it. And of course, back in our explanation, we do have extra explanations from Khan Academy. So if you want to check out their stuff, just to double check and make sure, you do not have to write x as an element of the reals. You don't have to write that. I'm not going to make you write that. That's for something else. We're not going to talk about that here. So it is a thing, but just be aware that I'm not going to make you write that. And that is the end of our inequalities section. So I hope that was helpful to you guys. And then, of course, here we've got the inequality question that I will be going over in the synchronous hours. I hope to see you there. And yeah, I'll see you then. That's the end of today's notes. You have an awesome day. I'll see you in the next one. Bye-bye.